Okay, so today we're going to talk about transformations of exponential functions. Okay, remember we did quadratics, so it's a times x minus h squared plus k. Okay, and then when we did radicals, it was a square root of x minus h plus k. So now it's going to be a to the b is just a base, x minus h plus k. So they all do the same thing. A still is your vertical stretch, h is still your left or right shift, k is still the up or down shift. So let's talk about the first one. So we have 1/4 to the x power. And what we need to do is we need to write this p of x with a shift of 2 to the right and 3 up. So q to the x is going to equal 1/4 x minus 2 plus 3. So we know that this is going to shift right 2 units. Okay, from that -2, remember that h is opposite of what you're used to. It's also going to shift up 3 units. Right 2 units, up 3 units. Okay. This one we need to complete the table. So it's 3 times 2 to the x plus 1. Okay, so this is my original function right here. This 3 means it's going to vertically stretch it by 3 units. Okay, this plus 1 means it's going to go up 1 unit. Okay, so let's go ahead. We're going to put -2 in. So it's 2 to the -2, which remember is 1 over. Remember, 2 to the -2 is the same as 1/2 squared, which is 1/4. So this is 1/4. Okay. And then we're going to multiply it by 3. Okay, so 1/4 times 3 is going to be 3/4. And then 3/4 plus 1 would be plus 4/4, which is 7/4. Okay, and then we're going to put the 0 into that same g of x function. So 2 to the 0 here would be 1. 1 times 3 is 3. 3 plus 1 is 4. Then for the next one, 2 squared is 4. 4 times 3 is 12. 12 plus 1 is 13. Okay, now for the next one, we have to use this function here. Okay, and we're going to put -2 in for x. Here, this part, okay, means that I have to find what is g at -1. So I need to put -1 into this function. Well, that would be 1/2 here. 3 times 1/2 would be 3/2. And then 3/2 plus 2/2 would be 5/2. So this would be 5/2 here, divided by 2. These 2 will cancel out, so I'm just looking at 5 minus 2, which is 3. So this would be 3. Okay, then I gotta do it again for the next one. Okay, this time it's 2g of 0, because our next x is 0 plus 1. And it's a 2g at 1. Okay, so we need to find what is g at 1. Well, if I put 1 in, 2 to the first is 2. 2 times 3 is 6. 6 plus 1 is 7. Down the rest of it. 2 times 7 is 14. 14 minus 2 is 12. Then we would do it again for the next one. So if I put 2 into that, it would be g at 3. So 2 to the third is 8. 8 times 3 is 24. 24 plus 1 is 25. So we're basically finding 2 times 25 minus 2, so it's 50 minus 2, which is 48. Okay. Alright, so it says graph m of x and n of x. Okay, so we need to graph m of x, so m of x I'll do in red. That's 2 to the x, so we go x, m of x, similar to what we did on the other day, so we're going to do -2, -1, 0, 1, and 2. If I put -2 there, that would be 1/4, 1/2, 1, 2, and 4. So I'm going to graph those points. 2, 1, 4, 1/2, 1, 2, 4. So here is my exponential function. Remember, I have an asymptote here at y equals 0. Okay? And then, my m of x equation, this part is my a, is going to reflect over the x-axis. So we're going to take each one of these points and reflect it over the x-axis. Okay, so that would be now there, 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 and there. So now, my new graph goes that way. Okay, so that's after the first transformation. This minus 3 means that it's going to go, remember, opposite, so it's going to go right 3. So every one of these points is going to shift right 3. So now, that's the second transformation. So then we also have this plus 2, which means everything is going to go up 2 units. So I'm going to shift everything up. And here is my new graph. So that purple one right there is my final graph. I do have an asymptote. My asymptote is always going to be my k value of y equals 2. Okay, so the graph below shows the already transformed graph that we need to go back to the original. So in the transformed graph, this negative 2 means that I'm going to go right 2. So, and then this plus 3 means I'm going to go up 3. But because we're going backwards, to go back to the original graph, I need to go left 2 and down 3. So I'm going to find points. So here's a point here I'm going to use. Here's a point. Here's a point. And here's a point. So each one of these points I'm going to shift left 2 and down 3. Okay, so here is what my new graph, my original C of x, looks like. Okay, so this one says the table below models transformation, complete the missing values. So I needed to go from the original to the transform. This plus 3 means it's going to go left 3 because it's opposite of what it is, and down 1. If it asks me to go backwards, then I got to do the opposite. I got to go right 3 and up 1. Okay, so let's take this first x. X is negative 6. Okay, if I'm at negative 6 and I'm going from the original to the transform, that means I need to go left 3 units. So I'm going to subtract 3 from negative 6. Well, that would give me negative 9. Okay? If I was going for my y, I'm going down 1, so I'm going to subtract 1, and that's going to be at 36. On the other side, we're going from negative 2 to the more positive end, so I need to add 3 to negative 2, so that's going to give me 1. I'm at 1/2, and I need to go up 1, so I need to add 1, so I'm going to be at 3 over 2, or 1.5. Okay, the next one, for my x, I'm going from negative 4 to my x prime, which is going left 3, because I'm going from left to right here, which means I need to subtract 3 from it, so that's going to give me negative 7. On the flip side, if I'm going from the transformed to the original, I got to go up 1, so I got to add 1, so that should be 17. Okay. For the functions, f of x equals negative 2 to the x, and g of x equals f to the x plus 3 plus 5. Alright, so here's my original function. In the original function, I still have this transformation this will reflect it over the x-axis. So instead of looking like this, it will now look like this. Okay? This plus 3 tells me it's going to go left 3. And this plus 5 tells me it's going to go up 5. Alright, so are the graphs f of x and g of x both decreasing? That is true. They are both going to go down from left to right because of that reflection on the original. Okay? Both graphs have a y-intercept at 0 and negative 1. That is not true. When I put in 0 for the original function, 2 to the 0 is 1, and 1 times negative 1 is negative 1. So it is true for f of x. But if I did that for g of x, if I put it in for g of x, because of the transformation, that will not be the same. Okay, they both have, g of x has an asymptote at y equal 5. That is true. It is the k value. Okay, that is also your asymptote. Okay, also your asymptote. Okay, g of x is shifted 3 units to the left. Yep, we said that right there. That is true. Both graphs have x-intercepts. That is false because look at this original equation. It will never cross the x-axis because of that asymptote of y equals 0. Okay. So f of x is the function shown below. We need to transform it, so it's going to go left 2 and down 3. Okay, so a prime, we're going to shift it a to a prime, we're going to shift it left 2 and down 3. So here's my new a prime, b, left 2, down 3. There's my b prime, and c, same thing, left 2, down 3. And c prime will end up at a, so it's going to go like this. Okay, so a prime ended at the coordinate negative 2, negative 2. b prime ended at negative 1, negative 1. And c prime ended at 0, comma 1.